ice. You can see here, we're gonna try to get in close. You can see larger dents, and there's actually a tear here in this one. Same impact, this is 2-inch impacts. And a 2-inch hailstone's moving anywhere from about 65 to 70 miles per hour. And you can see there's a nice dent. There's actually a crack there. That one's also got a pretty good dent. This one down here too, I'm gonna let Lauren just zoom in real quick as if he can. This is something that wouldn't hold up to a large hail event. So this was 2-inch laboratory impacted shingles.
So we're looking for the dents.
That's right, we're looking for those dents and tears. That's the most severe form, but you also can look for the patches of granules that come off. Now that's not this immediate crack tear concern, but over time, the more granules that come off, you're gonna expose that asphalt to ultraviolet or sunlight, and it actually becomes brittle and can become more susceptible to damage in the future. That's one of the areas that Brenna's working very hard on in a research space. So Terrence, we good to go? All right. And that is a beautiful soft impact. You see that nice slushy ice right there. Mm-hmm. And this particular product does quite well. We didn't even see a whole lot of granule loss on there either. So this is a good performer. We like to see that. Yeah. That's the stuff we want here at IBHS. And you know, I think back to when Tanya and I started working on this, you know, we saw some pretty poor performers. But we need to give some props out there to the shingle manufacturers who definitely have raised the performance of their impact rated products. We don't have a poor performer on our ratings as it sits today.
Awesome, science turned into action.
Absolutely.
Let's move to what might be the coolest part of all this here today. 3D scanning with our good buddy Ross. Let's talk about it.
Yeah, this is perhaps one of the most cutting edge things we do today is using a 3D laser scanning system to create high resolution digital models of hailstones. Ross has scanned more hail than anybody on the planet, pioneered this technology as part of our field program, and it's been used to document record hailstones from Texas to Colorado, and it's been used for us to understand all the little nitty-gritty details about hailstone shapes. You know, those little tiny lumps and bumps and spikes and all that fun stuff, to be able to, one, assess how their aerodynamics function. How do they tumble? How does weather radar actually see these kind of objects? Because we have these great digital models. And so Ross is actually going to take us through. This is actually a real hailstone that we collected in the field a couple of weeks ago during our very first field mission. We actually brought some back here to the lab, preserved in a freezer. And you notice Ross had them bagged up. So if you think you get a record hailstone at home, put them in a Ziploc freezer bag, contact your local National Weather Service office or your favorite broadcast meteorologist, and they can start that process.
That's literally what happens, right? Sometimes we get a Twitter message, maybe.
Yeah, that's right. It might be through social media, something like that. We've got a great table on our website of record hail for each state. So please go have a look at that. You can just Google search record hail IBHS and you'll find us. But that's, yeah, people have reached out to us on social media, and we work very closely with the National Weather Service to document these records, these really big hailstones that, you know, eventually they're going to melt, right? So we need to try to preserve them in a scientific way to be able to study them for later work.
All right, Ross, tell us what you're doing there, sir.
All right, so I've loaded in a scan template we use every time, so we're ready to scan. I've put the stone on the fixture, and we will give it a coating of compressed air so that it makes it visible to the scanner.
Now, folks at home, you may have actually heard of, you know, all the 3D printing work that's been going on. Mm-hmm. We can actually take these digital models and then 3D print these hailstones, and it's one of the ways we've been able to study how they tumble and what are their aerodynamic properties, because we can actually print them to the actual weight they are. And working with ice melts, right? So that makes life in science a little bit more challenging. But Ross has done this so many times. And you can see on the screen just this high resolution digital model of that particular hailstone that he's scanning right now. Ross, how long does it take you to do one of these in the field?
It varies in size and how much the stone's melting, but anywhere from 2 to 5 minutes, I'd say probably. Sometimes longer for larger stones.
All right, you've done some of the behemoths. What's your favorite? Your favorite of all time?
Probably the Salado stone, just how intricate it was. It was actually hard to even 3D print.
Yeah, we thought we had a follow-up to the Texas record a year after near Salado, Texas, and it was close, but it didn't get over the one that fell in Hondo the year prior. But as Ross mentioned, a very intricate shape, really neat to be able to go out to the field and make those scans of these really gargantuan hailstones.
And I've been here long enough to hear how excited you guys get when there's even the potential